soul. Now, the chemical properties of aliphatic ether, the important reactions pertaining to the HI. See, if I write here reaction with HI, you take in two conditions. One is the cold condition and this is the hot condition. I mean, one is the dilute and another is the concentrated. Therefore, once I take CH3OCS3 dimethyl ether and take HI in dilute, or I mean cold condition, then it is the H and I will be there. This is the methyl alcohol plus methyl iodide. It is the very much symmetrical ether. If I take unsymmetrical ether, then the preference order will be, always you keep in mind, alcohol in the long chain will be produced, CH3, CH2OH and then methyl iodide. One is the ethanol and other is the methyl iodide. See the other conditions. If I take symmetrical ether but take concentrated, I mean hot conditions of the HI, then this is the 2 times methyl iodide plus what is lost? Water, oxygen and H2O, and 2 iodines are there. It is very much symmetrical ether. But if I take unsymmetrical ether, like this is the CH3, CH2O, CS3 and take 2 times HI, hot and concentrated condition. Therefore, no doubt water is lost, but 2 different iodides are obtained. One is the ethyl iodide and other is the methyl iodide. One reaction is very much given. Write the reaction mechanism of dimethyl ether with HI. Write a question and solve it, everybody. Write the mechanism. Write the mechanism of HI with dimethyl ether. That is the exercise question. Important and probable question for your forthcoming examination. See here. I take first of all step 1, CH3OCS3, it is a base, it acts as a nucleophile and HI is there. Now this lone pair is donated to the H delta positive and it is delta negative. Therefore CH3OH positive charge, lone pair and CH3 and iodide is still there. Dimethyl oxonium ion. Dimethyl oxonium ion. Now it is to be carried out in the step 2, or you can have the chain mechanism also. Both are acceptable. Otherwise, to make your study more systematic and simple, I used to have the stepwise mechanism just for your convenience. Dear students, here iodide acts as a nucleophile. And take this one, CH3OH, then CH3 and positive charge in the lone pair. This carbon will provide the electron and then it becomes positive, and this nucleophile will be provided here, CH3I and then CH3OH. So just to remember, when you have taken the dilute HI, then you got the 2 products. One is the alkyl iodide and another is the alcohol. I mean, here we have taken methyl, so it is methyl alcohol or methanol. But see, once I change, further I take CH3OH and HI. This is what actually this lone pair is donated to this point here. Then CH3OH positive charge and lone pair. Methyl oxonium ion. Right, and the fourth is I take CH3 and that is the iodide is here. Now still we take it we'll take it help as a nucleophile plus CS3OH positive charge in lone pair. This will be provided here. It becomes the positive charge. So dear student, it becomes methyl iodide and water is lost. So remarkable products are there in the mechanism of HI is the methoxymethane. First is the methyl alcohol, methyl iodide and methyl alcohol. Other is the methyl iodide and water molecule is lost. So this is the reaction mechanism of dimethyl ether with HI. Now the other question in your book is, that is, the reaction is given to you is not the given reaction is not appropriate for ether. Question is given like CH3, CH3, CH3Br and NaOC2H5. Although you take nucleophilic substitution reaction, and what is lost? It is what kind of the halide? It is no doubt 3-degree alkyl halide. You remember in Williamson synthesis, it is defined as when primary alkyl halides are made to react with sodium alkoxide to form symmetrical as well as unsymmetrical ether. But here, dear students, we have taken 3-degree halide. So is it some sort of violation of the, Williamson synthesis? But still, whatever the ether is produced with the help of the nucleophilic substitution reaction, then it becomes CH3, CH3, this is the O, and C2H5. But this ether has no very good yielding, so you can say it is the minor ether. No doubt we got the ether, but this is the poor yielding of the ether. What is the name of this? Common name is the TERT or tertiary butyl bromide. Or in IPEX system it is the 1, 2 or 3 or 3. So 2-bromo in IPEX system, 2-bromo, 2-methyl propane. Only you just go for IPEX system of nomenclature. So you will revive and revamp your previous knowledge. Apply your knowledge in every part. Here it is the 1, this is the 2 and this is the 3. 2-ethoxy, 2-methyl. So IPEX system is the 2-ethoxy, 2-methyl. What is that? Propane or butyl, tertiary butyl, tert, butyl, ethyl, ether. It is the common name. But this ether, whatever we got, point is to be noted, this ether, whatever we got is the minor ether. Because we have taken, one is the 3-degree halide, and second it is as a part of the nucleophilic substitution reaction. Therefore, the question is, what will be the major product from the given reaction? Now, it is the one question. Question 2, write the major products from the given reaction. Since it is the 3-degree halide, so dear student, please follow here. Important point is that Br, since this sodium ethoxide act as a strong base, it acts as a strong base as well as a strong nucleophile. So actually it refers alpha beta elimination reaction, and the above reaction was the nucleophilic substitution reaction. But sodium ethoxide, due to the alkali metal, it acts as a strong base, and since there is a lone pair of the electron, so it acts as a Lewis base. So both the purpose that is being carried out by the sodium alkoxide, that is what it is, the strong base and as nucleophile, so it will follow alpha beta elimination. Alpha के बाद beta can be here, beta can be here and beta can be here. One observation is very much made it clear that all betas are at the equivalent point. That is why, keep in mind and retain this point, they follow alpha beta elimination, and alkene must be formed and be preferred as the major products. Therefore, it is minus NaBr and minus water. Sorry, C2H5 minus this C2H5OH. Then what is the product formed? CH2 double bond CH3 and CH3. This is the 1, this is the 2, and this is the 2-methyl prop 1-ene. This is the 2-methyl prop 1-ene. Is what product here? This is very much major product. Then the question arises. The question is, if it is the major product from the alpha beta elimination, then you are assigned to prepare ether with the help of the above reaction. How can you prepare ether? By taking the above reaction. Therefore, it is a matter of swapping. Swapping is actually change the position. Whatever it is given to us, what we do, just you make it sodium tertiary butoxide. This part will be here and this part will be, this whole part will be there. So dear students, here CH3, this is the bromo, CH3 and CH3, and this is the ONA, sodium tertiary butoxide, sodium tert butoxide plus Br. This is the CH2 and CH3. It is 1 degree halide. Purpose is solved. Just it is a kind of swapping. ONA is replaced with the help of bromide. Now it will not act as a strong base as well as nucleophile. So this is the NaBr is replaced here. It is very much nucleophilic substitution reaction, and major ether is obtained, CH3, CH3O and C2H5, ethyl tertiary butyl ethyl ether. It is the major product, tertiary butyl ethyl, and what is that? Ether. I hope it is clear to everybody. So just to go through the reaction and prepare yourself for the forthcoming examination. Now I take other question from your textbook to discuss here. Conversion. Very few conversions are given here. Only the mechanisms part important and the name reactions are important. Before that, solve some question here. Is like predict the products of the following reaction. Complete the following. What the question is given here? First question is, that is the 11.12 NCERT. This is the in-text question. These are the in-text question is that CH3, CH2, CH2O and then CH3 is made to react with HBr. This I have told you earlier, long chain carbon carrying alcohol, CH3, CH2, CH2OH plus CH3 and Br is alright. Go for the second question. Phenitol is here. C2H5. Actually it is phenitol or ethoxybenzene. Now added with HBr. Tell me anybody the product formed. H will be there. Phenol is stabilized by the resonance and then C2H5 Br is obtained. The third question from your book. Phenitol or whatever anisole It is very much phenol. Nitration takes place with the help of this and this. Therefore, one is the ortho product, another is the para product. Ortho is the minor and para is the major. Therefore, this is OC2H5. It is orthonitrophenol and other is ortho, meta and para nitrophenol. Fourth question is bit tricky and important. It is the CS3 whole thrice. Just you open the structure before the paper. I do advise you, I have given you the piece of advice from time to time. Whenever you find difficulties in solving questions, let you first open the structure. Either the question may be the IPAC system of nomenclature or complete the reaction, whatever it is. Just to go for few minutes on rough work, homework, and before putting your answer in a very cementing form. So examiner will be more happy if you open the structure and make it circle to eliminate the side products and the major products are formed. It will be much easier for evaluation part also, as I feel that I become the examiner and there I can have this kind of easier way for evaluation. So therefore it is made to react with HI, and then here is more stable carbocation will be attracted by the greater size of the nucleophile. So see here, here is C2O C2H5. This is the question. C2H5. Tertiary butyl ethyl ether. So here CS3 iodide. Iodide becomes the bigger nucleophile and is the bigger carbocation. So bigger carbocation attracts the bigger nucleophile and then ethyl alcohols are formed. So these are the questions pertaining to the ether. Now other type of question very much given is like, say, give you the question and then complete the following. Complete the following reaction: CH3 CH2 CS3, then this is the CH2O CS2 and CS3, then HI. So obviously H will be there and iodine will be here. Then it forms CS3 CH2I plus CH3 CH2 CH CS3 and CS2, and what is that? OH. Question number 2 is the benzyl is CH2O phenyl ether. So HI is added here. So this H will be there and iodide will be here. Benzyl iodide. This is benzyl iodide plus, what is that? Phenol is formed. Question number 3 is this is what? CH3 CH2 CH2O, then CH3 C2H5 and CH3. As I have told you earlier, this iodide will be there and H will be here. This part is going to give the right answer. This is the CH3 CH2 CH2OH plus C2H5 CH3 CH3, and what is that? Iodide ions are formed. Now you remember the Kolb reaction, Williamson synthesis, Raymond-Diamond reactions, and then how are the following conversions carried out? Now the next question from your textbook is that conversions, that is the propene to propane to all. conversions from the exercise question, that is the 11.20. It is the exercise. First is the propene to propane to all. You can go for the hydrolysis, double bond CH2, add the water molecule in presence of S positive, apply the Marconi-Koch rule here. Negative part of the addendum goes to the doubly bonded carbon carrying the less number of hydrogen, and this S will be there. Contrary to this, if peroxide has been provided, then you follow the anti-Marconi-Koch rule or Mayo or Kharash effect, peroxide effect. But here we follow Marconi-Koch rule. CS3, CH, OH and CS3. Question number 2 is that, see, benzyl chloride to benzyl alcohol. So here I write benzyl chloride to benzyl alcohol. You remember in haloalkane and haloarenes I have solved around 25 conversions. Always you go for practice all the conversions. This same question is there now. In back-to-back class I have explained you know, exhaustive way of discussion so far as conversion is concerned, because of conversion is nothing but it requires practice based on the method of preparation and the chemical properties. If you have command or mastery over these two parts, then conversion is very simple part. See, benzyl chloride, once you follow with aqueous NaOH or KOH, nucleophilic substitution reaction minus NaCl, then it forms benzyl alcohol. Right, 1-phenyl methanol in the Aliphatic system of nomenclature. Now next is the methyl magnesium bromide 2. Methyl magnesium bromide 2-methyl propane 2-all. So dear students, during the discussion of, I have uploaded the method of preparation of the alcohol, and there we apply, there is one method, Grignard reagent, Victor Grignard. With the help of that reagent we have prepared all the 3 types of the alcohol, primary, secondary as well as tertiary alcohol. That's the same part from that. You take methyl magnesium bromide. It is the Grignard reagent and it is for 3-degree alcohol. That point is important here. You take acetone, or you can take propanone, or you can take dimethyl ketone. So addition takes place here. CS3, 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 CO, Mg, Br. Tell me what is the name of this? No nomenclature. It is called as adduct. What you do now? As anyone? Before the product adduct is formed, it must be followed by hydrolysis. So whenever they undergo hydrolysis to form, this is Br. Water is added in acidic medium. It is the water. This H will be here, and this part is to be taken out. What part is here obtained? CS3, CH3, CS3OH plus MgOH and Br. This is the side product, but it is called as 1, 2 and 3. 2-methyl propane to all. 2-methyl propane to all. Just to go through all these questions, and then 1-phenyl ethanol from a suitable alkene. Another conversion is from the same chapter is how can you get 1-phenyl ethanol from suitable alkene. So you take this kind of alkene is CH double bond CH, vinyl benzene, vinyl benzene, or it is known as, what is that, polymer chemistry, polystyrene is formed, or phenylethylene. Either you say vinyl benzene, phenylethylene, or styrene. Polyester is one of the important commercial products of polymer. So you apply the Markovnikov rule. In acidic medium, OH should be there at one point and H will be there. CH3, CH, OH, and this is what? It is the 1 or it is the 2. 1-phenyl ethanol. 1-phenyl ethanol. That is what it is, the cyclohexane methanol using same questions now. And dear students, see the other question that I do collect from your book. Write the reaction of Williams synthesis, follow the Williams synthesis and prepare the following compounds. What the compounds are given to you? Question is from ethanol and 3-methyl pentane-2-ol. Prepare 2-ethoxy 3-methyl pentane, 2-ethoxy 3-methyl pentane by ethanol and what is that? 3-methyl pentane-2-ol. 3-methyl pentane-2-ol. With the help of follow what reaction? Follow, question is given, Williamson reaction. So keep in mind what is the definition of the Williamson reaction. Again, primary alkyl halides are made to react with sodium metal and sodium alkoxide and all. So we are given two things, and what you have to prepare? 2-ethoxy 3-methyl pentane. If I write here 2-ethoxy 3-methyl pentane, 1, 2, 3, 4 and 5. 1, 2, 3, 4 and 5. 2-ethoxy 3-methyl, 2-ethoxy 3-methyl pentane, CH, H, CH3 and CS2. This is the product. This is the 1, this is the 2, 3, 4 and what is that? 5. So first to draw the structure is that 2-ethoxy 3-methyl and pentane. You are given ethanol. So first you take the ethanol here and you just change it into the primary alcohol. Either you will react with sodium metal, then it forms, what is that? This is the C2H5ONA, sodium ethoxide. Then it forms H2, half time lost here, and the one reagent is prepared, sodium ethoxide, right? So this is the wrong, I think, because of once we have to take primary halide. So better to take PCl5 or thionyl chloride. You take minus PuCl3 minus HCl, C2H5Cl. One is obtained. Second, it is 1 degree halide. Because of primary alkyl halide must be taken. Second is, that is the 3-methyl pentane-2-ol. You write here 1, 2, 3, 4 and 5. 1, 2, 3, 4 and 5. 3-methyl, 1, 2, 3. 3-methyl pentane-2-ol. CH3, CH, CH, CS2 and CS3. Another reagent is given here. So ethanol is given and 3-methyl pentanol is given here. But here we have to take a metal like sodium, H2, half time hydrogen gas is lost and sodium will be there. It becomes CH3, CS2CH, CH3 and then CH, CS3, O and A. Whatever the product is formed, A plus B combined together. Here is the Cl and here is the Na is lost here. Whenever Na and Cl is lost, C minus NaCl. Then what is formed? CS3, CH2CH, CS3, CH, O, C2H5 and CS3. 1, 2, 3, 4 and 5. 2-ethoxy, 3-methyl, 2-ethoxy, 3-methyl pentane. What the product? Before that I have written 2-ethoxy, 3-methyl pentane. So what we did first of all alcohol is given. Our job is to get primary alkyl halides. Here sodium alkoxide. Then these two will react, A plus B, this reaction and this reaction whenever combined together to give the product is obtained. So I hope most of the questions I have explained you. It requires exhaustive practice and then we will be able to solve the question. Go through all and make notes and prepare for the paper. Thank you very much and have a nice day. God bless you.